I'm AJ with Acclivity, and I get to walk you through some new capabilities in Zilla. Let's get started looking at what the common OpenAPI Petstore example looks like using Zilla. Here we have a common OpenAPI Petstore example. This example implements the pet endpoints, allowing you to create new pets, update existing pets, delete pets, and get a list of pets. Zilla can implement this OpenAPI spec in order to proxy these endpoints onto and off of Kafka. But what is Zilla? Zilla is a multi-protocol event-native edge and service proxy. Its declarative config allows you to define your API endpoints in the native protocol. Here we're looking at a OpenAPI spec, which Zilla is able to parse natively without any external dependencies like parsers or generators. This means the API endpoints defined in the OpenAPI spec can be used to proxy messages on and off of Kafka. Let's see what that looks like. Back at our Petstore OpenAPI example, these API endpoints are being implemented by Zilla. This means I can post a new message to this API endpoint and see it show up on Kafka. Now the message is on Kafka. When we do the get endpoint, we are going to fetch all of the objects messages that have been posted onto that Kafka topic. Let's look at what this architecture looks like with and without Zilla. Traditionally, you would need a Kafka REST proxy in order to synchronously produce and consume messages on and off of Kafka. That means your OpenAPI spec would be implemented as a web server so that the web client can communicate with it, and then a separate basic authentication layer would be added latency onto the Kafka REST proxy. With Zilla, all that is in one. Zilla implements that OpenAPI spec and those REST endpoints for you, allowing you to synchronously produce and consume those messages directly onto your Kafka. Additionally, because Zilla is event native and it allows you to define your own REST endpoints, you can define asynchronous REST endpoints, giving you the flexibility to make your front ends more event native. This means that HTTP clients can produce and consume messages without having to wait for the backend operation to finish. Here we have an AsyncAPI schema. It is purposely very similar to an OpenAPI schema in that it's defining your API services using the same kind of information like servers and operations. Instead, an AsyncAPI schema is defining your event-native APIs. This AsyncAPI schema is defining our Kafka API that we're using for our Petstore demo. In our Petstore example, we can see things like our list pets and add pet operations. These map directly to the OpenAPI operations, allowing for Zilla to map those REST calls down to the Kafka API, enabling Zilla to implement the REST Kafka proxy using both the OpenAPI and AsyncAPI schema specs. Our asynchronous API call is going to be this create customer operation. Here in the AsyncAPI spec, we can see we have our Petstore customers topic created and a create customer operation ID. This operation also defines the reply information. This is defining the reply channel that Zilla is going to use to proxy the asynchronous request, meaning the HTTP client is going to make the initial request on the Petstore customers channel, and the asynchronous reply is going to come on the Petstore verified customers channel. Let's look at the Zilla config example to see how these OpenAPI and AsyncAPI schemas are used to define all these API interfaces. Here we have our Zilla config. In the Zilla config, we have our north REST server defined using the OpenAPI schema and our south Kafka client defined using the AsyncAPI schema. Zilla has an OpenAPI to AsyncAPI proxy binding that allows the connection between the two different schemas by routing each of the operations. Our schema definitions are being stored in an Apicurio registry. Zilla defines the catalog for the Apicurio registry, allowing us to access any schemas deployed inside of that registry. Zilla is pulling those schemas by name and version dynamically meaning we can update our API endpoints by updating our schema configs in the registry directly without having to change Zilla. Right now, we've only seen the version 1 of the Petstore API. Let's go ahead and deploy the version 2 that has our asynchronous API endpoints. To do that, all we have to do is deploy Zilla with a new environment variable with the v2 Petstore version. Now that that's deployed, let's go see what an asynchronous endpoint looks like when being proxied through Zilla. Here we have the v2 OpenAPI spec that we just deployed in Zilla loaded into Postman. As you can see, we have updated endpoints and updated pet models. These new pet models we can post to Kafka through Zilla. We still get the same successful no content, and importantly, Zilla is also validating these messages. Meaning, if I try to put some invalid information into this model, Zilla is going to send back and reject that message. As soon as I put a valid message, it's successful. Now let's look at what an asynchronous request looks like. For this, we're going to be using the customer endpoints for creating an unverified customer and then waiting for a verified response to come back. The create unverified customers endpoint allows us to publish a customer object to the Petstore customers topic using the prefer respond async header. This tells Zilla that we want a response immediately with a location header that will be the location order for the client to fetch for the result of that asynchronous call. Here we're going to go ahead and send this call in and get that location header. We've just received the 202 accepted from Zilla, meaning that this location header has this correlation ID, and that if we do another prefer wait header request from the client, then we can wait as long as, or the client can wait as long as it needs to for the response to come back. Here we're going to go ahead and take this location header, put it in our GET request with the correct correlation ID, and set our prefer wait header, allowing for the client to make the call to Zilla asking for the response and telling Zilla how long it's willing to wait for that response. Zilla will reply to that client as soon as the message shows up onto Kafka, onto the reply to topic. The message has been delivered to our reply to topic with the approved status for this customer. Let's go back to see if our client request has finished. And yes, we can see our client request came back with the exact same payload with status being approved. We've just seen that with Zilla, you can easily implement both OpenAPI and AsyncAPI schemas, allowing you to publish and maintain synchronous and asynchronous API endpoints, lowering the bar for event-native workflows. Thank you for joining me for this demo.